Welcome back, my fabulous chemistry students. Video number 8. 6, 7, 8. Video number 8. Lewis dots for covalent molecules now. So we learned how to do ionics. We're going to find there's a little bit different of a rules for Lewis dots. This way, when I look at the diagram and I know both rules, I'll instantly know, is it ionic or is it covalent? And the other way around is then I have to know based on the names if is it ionic or covalent, so I draw it the right way and use the right rules. So no brackets, no charges. We have to share electrons. That's the biggest thing that this is going to show us, how we share them. So it says we need to write the element symbols and draw their valence electrons just like we did before. And then we're going to place the most electronegative atom in the center. So oxygen a lot of time is the central atom. Carbon is almost always the central atom. Okay, carbon, central, both start with C. So I'm going to start here. I'm going to start with the oxygen, and I have 1, 2, 3, 4, 5, 6 valence electrons. And I have hydrogen. He's got 1, and I got hydrogen. He's got 1. So I'm going to start at color coding. When you are doing with pen and paper, the other thing you could do is instead of color coding, because you can't do it, you don't have to color different color pencils. One of the other things we can do, I'll do it again with same color now so you can see how you do it at home or in the classroom. I can do a little X for this. Oopsies. Silly me. Now I gotta wait again because we have a ghost in the eraser here on the smartboard for some reason. I can do X's for certain electrons, and this way I can see what electrons went from where. I can color code it, or I can shape code my valence electrons, however you prefer, really. With the same color, same color pen, you're probably better off doing this particular method. So what's going to end up happening is this is going to work like a puzzle now. I'm going to end up putting this X over here and this X over here. Let's go on to the next piece, and it'll tell us a little bit about that. And it says draw dashed lines between the elements connecting all the lone pairs. Your goal is to pair up all of the unpaired electrons. So let me go back. I know you're just looking at it on one page. So I'm going to literally take this piece and I'm going to move it. Oh, cool. Look at that, Mr. Milks. I could do it. Let's get rid of that. Where's my mousey house? My mouse. Get rid of this. Oh, I like this. All right, get rid of that. Now watch. I can take this and I can slide it right up in there. Right? You're doing good. Mr. Milks, it was doing good. Oh, now it's not doing so good. Let's try it again. See, it's going to go right up in there. And this was by itself. And it's going to slide in there. Whoa! Whoa! Okay, enough games, Mr. Milks. You're making me dizzy. Anyways, they're going to slide in there. And that's what we're going to show on the next page, okay? On the Pogo, you're going to see we actually have puzzle pieces for you to put together, more like puzzle pieces. So let me draw this. I'm going to do this one now in 2 different colors. Instead of X's and dots, I'm going to do it in 2 colors because I have that ability right now. So I have O, 1, 2, 3, 4, 5, 6, and that's how many it's got, is 6. Then I'm going to have an H here, and I'm going to have an H here. Now notice the H's are not on either side. Because if I follow the rules of how I do my original Lewis dot with, first 2 together and then 1 at a time around the bus, I'll see oxygen actually ends up with, water ends up with this bent L type of a shape. And it gives water a lot of its, properties that make it so very unique. And we'll study those properties in future units. So now I need to draw a dashed line to do a single bond. So here where I have a red and a blue electron together, those are going to form what's called a bond. So the nucleus of the oxygen is going to attract the electron of the hydrogen, bring them on over. And the same the other way. The hydrogen's nucleus is going to attract the electron of the oxygen and bring them on over, and they're going to start sharing those electrons, and that's what's going to make the bond. So when we write it, we put this single bond now in between. I could rewrite it real quick like this, but then I still need to show my lone pairs. And that's how we get from here to here, I replace these bonded pieces with this dash. And see, this is this dash, and this is why I never wanted you to show those outside electrons like that, because it starts to look like you're making a dash or a bond, and the bond shows that the electrons came from two different locations. Okay, so rules as far as bonds go. The number of electrons being shared by the carbons is 2. Okay, so in this case here, this bond is, I have an electron from one carbon, an electron from another. I can replace those two different colored dots with a dash. There is 2 electrons in there, and it says the number of electron pairs being shared between the carbons. Well, it's only one pair of electrons. Okay, so one bond, because a bond is a pair. So I get a double bond is when I have 2 pairs of electrons, or 4. And we'll see how when we do that. So the number of electrons being shared now is 4 with 2 bonds, or 2 pairs. A pair is a bond. So there we go. Now we got one more, of course. If we had single and we had double, now we're going to triple. Okay, I hope this video works out okay, because I see it kind of up. Maybe it's not going to work. Maybe it's not going to work. I'm not going to like it. It's going to drive me nuts. But anyways, 3 dashed lines is what we call a triple bond. Triple bond, I must be sharing 6 electrons with 3 pairs, or 3 bonds. Okay? Now we went through this pretty fast. We'll do a little bit of practice. We'll call it a video. And of course, I'm going to have lots and lots of practice, in the classroom with me. Right there with you to help you. Okay? H and Cl, I have H with 1 dot. I have Cl with 7 dots. Dots being electrons. This one here is going to come in over here, and now I can rewrite it H-Cl just like that. Okay, N2. N has 1, 2, 3, 4, 5. N has, oh, I better do a different color N though, Mr. Milk, so we're not going to be able to separate them. How about red and green this time? Go away. Go away. N, 1, 2, 3, 4, 5. Okay, so I'm going to get these 2 to bond. I'm going to get these 2 to bond. And then I'm going to get these 2 to bond. Now, wherever I drew those things, I'm going to put bonds. I could draw them out with red and green electrons like I did the first 2 times. But now I'm starting to get a feel for it. Here's a red one and a green one. It's going to form a dash. So I have N with 1, 2, 3 dashes, because nitrogen notoriously forms a triple bond. Now I'm going to bring those other 2 electrons down here, because if they're up here on the top, right, and you can kind of see that I can see the top, but you can't see the top. If they were up here, right, there'd be 2 negatives right there. And what would 2 negatives do? They would repel, and they would want to be as far apart from each other as they can be. So it's very common to draw it the way I just did. Granted, I have a whole lot of that, what we call instinct, but you will get there as you do more of these. CCl4 and NH3. CCl4. Interesting here. Oh, we are doing covalents, so okay, good. These are all covalents. So C, remember C has got 1, 2, 3, 4, and we draw it like this, and now chlorine's got 2, 3, 4, 5, 6, 7. And what's going to end up happening is these 2 are going to hook up. And there's going to be 4 Cls. And they're just going to all hook in, okay? We got to be able to solve the puzzle. Okay. Notice I manipulated how I drew those to make them go a little faster. So it's going to end up being C with 4 bonds with a Cl on either side, okay? What I have to make sure I do, though, is I have to include all the rest of the valence electrons. Now, I included a tutorial in the practice for how to do these, and I really like how it breaks down counting up the electrons. Yeah, I think you might like that method. We'll do that method in class together, where we actually count all the valence electrons and distribute them in a certain way, and then I can figure out, do I draw double bonds or single bonds or triple bonds. All that stuff's all worked out, and the process is very what we call robust. It's going to work for everything you see pretty much without an exception, which is robust. I like that. Now, we can do Lewis dots for covalence. Before we could do it with ionics, hint, check first before you start drawing, is it an ionic compound or is it a covalent compound? You got to know which one to draw because remember, ionics need A, B, C, D. Atoms, brackets, charges, dots. Covalents just have the symbols with the electrons around and how they spread out, and you can see their shape a little bit better, but they work together more just like puzzle pieces because we're sharing electrons. That's what it's meant to show us, okay? So I'll see you guys tomorrow in class. Sorry the video went over a little bit, but there's a lot to it, and we will be done drawing Lewis dots before too long.